Hi everyone. Today I will talk about sampling of liquid and gases, sample storage and preservation, preparing a laboratory sample, and replicate sample. Proceed. For sampling of liquid sample are much easier due to liquid samples are homogeneous. If liquid samples are not homogeneous, what you should do is you need to shake the container, then sample it immediately. To sample the liquid, it may depends on the types of liquid itself. So if let's say you deal with a large volume of liquid, it is impossible to mix, such as, for example, you have in your college, you have the tank, water tank is big enough, right? So it is impossible to mix. So what you should do is the best to sample several portion of the container with a sample tip. Fill at any desired location in the solution. Okay, I would like you to find the terms of sample tip. Please be respond after this. And then if let's say you deal with a large stationary liquid such as lakes and rivers, the constituents of liquid may vary according to depth. So what you should do is water sample is collected at the surface, middle, and at the bottoms of the riverbed. Okay, so second point is settled. The third point is biological fluid. Biological fluid, for example, is serum, plasma, urine, and blood, and etc. For example, all COVID patients who have been cured are called back to the hospital to get their plasma fluid in order to help other positive COVID-19 patients. Check point number 3. Okay, now we proceed to sampling of gases. For sampling of gases, it's much more easier due to gases tend to be homogeneous. But it requires a large volume since gases has a low density. So to collect the gases sample, there are a few techniques and instruments or tools can be used. Okay, the instrument is such as for air analysis, you need to use a high volume sampler as shown at right side of your slide. This one. This high volume sampler, it containing a filter to collect the particulate. After a specified of time, the filter in the high volume sampler will be removed and taken to the laboratory for further analysis. So the second one is liquid displacement method, where the sample mass has little solubility in the liquid and does not react with the liquid itself. Then the breath sample. The breath sample, the subject could blow into evacuated bag, flask, bottle, or other suitable container. For example, alcohol analyzer. You need to done it over a period of few seconds or up 1 to 2 minutes. You cannot blow it more than 1 to 2 minutes because your evacuated bag akan full. So normally for TB patients, you need to blow it into evacuated bag. Alright, now we move to sample storage and preservation. The main objective of sample storage is to protect it from contamination or alteration. So it to protect your sample. So several precautions should be observed in handling and storing sample before the actual analysis is carried out. Maybe sometimes you do a sampling of your samples sebulan yang lepas. So bila nak guna pakai tu, bila you nak guna pakai when you want to use your sample, so you kena ada proper storage. This is to prevent the sample from contamination, right? Prevent the contamination or alteration that may caused by the container, so the atmosphere or the light. And then the second one is loss of the analyte due to exposure to atmosphere or absorption onto the wall of the container. And the last one is decomposition due light, heat or bacteria, right? So you need to know what this, because some of your sample dia unstable actually. Okay, then we proceed to sample storage. For liquid sample, make sure that it's kept in bottle with stopper. For acidic liquid, you need to be stored in glass container, while the basic liquid you need to store in plastic container. So trace amount of metal you should not be stored in glass container, because glass can leach small amount of metal. Okay, so you need to remember glass is made up from calcium carbonate. Maybe calcium metal will leach. Alright. Trace organic compound may react with plastic container. So maybe sometimes you need to add some preservative to unstable sample. For example, sodium chloride is added to blood sample to preserve the blood. Sample also need to be stored in refrigerator to avoid decomposition of sample from bacterial sources. Alright, so proceed to preparing a laboratory sample. So where we need to convert the sample to useful form. So normally for solid samples are usually ground to a suitable particulate size to get a homogeneous sample. At the same time, if let's say you ground the stone, so you want to have the size of your sample is micro size, so you need to sieve the ground stone, right? Dry the sample to get rid of absorption water. This is must, okay, to do, because but there is a problem associated with drying of sample, where the samples might decompose at high temperature. Some samples are very sensitive to heat, so you need to carry out the drying process in desiccator. So we have a lot of desiccator in our lab. Okay, then there is a side reaction can occur during storage of sample. For example, liquid sample, sometimes there is a loss of analyte due to its volatility, so the container should be closed tightly. Okay, next to defining a replicate sample, what does it mean by replicate sample? So since you have a sample, so you need to replicate your samples. Okay, replicate sample are always performed unless the quantity of the analyte, expenses, cost or other factor prohibit. Okay, replicate sample are portion of material of approximately the same size that is carried out through the same analytical procedure at the same times and the same place. So the function of this replicate sample in order to make sure your analysis is reliable. Okay, and the last part is preparing solution of the sample. So a solvent is chosen that dissolve the whole sample without decomposing the analyte. So it's very important to choose the right solvent. Okay, sources of error, if let's say you choose a wrong solvent, so maybe there is an incomplete dissolution of your analyte. Losses of analyte by their volatilization, introduction of analyte as a solvent contamination, and the last one is contamination from the reaction of the solvent with the vessel wall. So as I said, once again, you need to choose the correct solvent for the correct sample. That's all for chapter 4b. Thank you.